Hi, my name is Nathan Baduma, and today I'll be going over alternative mechanisms for photosynthesis, in particular C4 and CAM. I'll first be talking about C4 plants. So C4 plants are important because they use an alternative form of carbon fixation, especially when the climate is extremely dry and hot, and the stomata have to close up. When the stomata closes up, the levels of carbon dioxide in the cell decrease, and levels of oxygen increase. And regular Rubisco in the Calvin cycle actually has a higher affinity for oxygen in this environment, and this leads to a phenomenon called photorespiration, and this is extremely inefficient for the cell. So as a result, a new type of photosynthesis, or a new subsection of photosynthesis, evolved, especially in terms of the Calvin cycle. And this has to do with C4 and sugarcane plants, corn, etc. And C4 involves two different types of cells, the bundle sheath cells and the mesophyll cells. As you can tell from the name, the bundle sheath cells tightly wrap onto the vascular bundle, and the mesophyll is located on the outside. So, from this structure, you can tell that the mesophyll cells carry out the first step, and the bundle sheath cells receive the products, which we'll be talking about in the next slide. So the first step is carried out in the mesophyll, and PEP, phosphoenolpyruvate carboxylase, is important because it fixes the CO2 in this climate and forms a 4-carbon product called oxaloacetate. And PEP carboxylase has a much higher affinity for carbon dioxide in these conditions. So it's much more beneficial for the cell to use this enzyme. And as I stated earlier, it works well when the carbon dioxide levels are low and the oxygen levels are high. So after a couple of steps, oxaloacetate is converted to malate. This 4-carbon product is then transported to the bundle sheath cells, where carbon dioxide is released from malate, and then it undergoes the normal Calvin cycle. And Calvin cycle can be used in this case because there's a high concentration of carbon dioxide in the bundle sheath cells, because carbon dioxide is being selectively released in these cells. So there's no real competition between the carbon dioxide and oxygen to be used in the Calvin cycle. And this Calvin cycle then produces sugar, and the normal process is then complete, and going into the vascular tissue can be transported to the rest of the cell or stored. The second type of photosynthesis I'm going to be talking about is CAM, or crassulacean acid metabolism. So in these types of plants, stomata are open at night and closed during the day, which is the opposite of normal. And during the day, light reactions can supply the plant with ATP or NADPH for the Calvin cycle. And the mesophyll cells actually store organic acids at night, which are produced at night, and then these acids can be metabolized during the day and can go into and release CO2 and then go into the Calvin cycle to produce sugars using the ATP and NADPH that is supplied by the light reactions. I hope this video explained the alternative pathways of photosynthesis C4 and CAM. That's all for today. Thank you for watching.